So I would like to introduce myself. My name is Marek Mos. I work here at Miquido in Krakow, and I would like to share with you the talk. My topic will be "Fake it till you make it." So first of all, I would like to thank for this great opportunity to be speaking in front of such a great audience here at Mobiconf, and it's there are plenty of great speakers here at conference that it's really hard to fill in their shoes. My talk will be quite simple, not some super advanced stuff, just my thoughts and some observations that I make during recent years, and I'd like to share them with you. So, okay, so let's start with a simple hypothetical question. So, what would happen if the internet connection broke? So, you're just sitting in your office, type in your app, and suddenly the internet connection breaks. So, would you survive? So, you just open your terminal, write some ping command, and all you can see is just a bunch of request timeouts. You cannot access your web services that you are talking to, nothing works, and happily, I think that most of you would just continue work on your app, just use some different way to receive the data, and just don't integrate with this web services during this certain day. But unfortunately, that's not the case most of the times. Even now, if on the ongoing application that I'm currently in, if I hadn't got any internet connection, I would just stop working. And this is what we can see: a whole team just go play football or ping pong because they cannot reach the servers, and of course, without any data, they can't present anything in their application. But how much code really rely on the internet connection so strongly? And of course, there are some advanced cases, but in simple cases, it's maybe even one object in your whole application. So there is a one object that is talking to the web, and whole the application, if this object cannot function well, all the application is down and we cannot continue work. And even if there is an internet connection, it can be really unreliable. Some packets can get lost. It is pretty slow sometimes, and so on. Many problems. So the answer to this, of course, are unit tests. And when I'm talking about unit tests, of course, let's talk about TDD. I will just mention because it's not talk about test-driven development. But of course, if we are doing TDD in our app, we don't care about any dependencies at all. We just get the object that we would like to code. We write a bunch of tests, red, green refactor, red, green refactor. We just launch our tests, implement the functionalities, and we don't even need to run our app at all. So recently, when I was working on an app using TDD, I didn't open my app almost none of the time. And when we start to talk about TDD unit testing, the first question that arises is how to test the views. What about them? Because especially in the iOS and in those UI apps, the user interface is a big part of the application. So how to test the views? And the answer is quite simple, and I'd like to show you. So here is an example UI. So this is just a screen with some simple fancy animation, and of course this animation is driven by a couple of parameters. There is some spring dumping, spring velocity, animation time, and of course there are a couple parameters that drives this pen gesture. So when the buttons collapse, when they expand, and so on. So how to write the unit test, for example, for such a view? And the example is really simple. Here's the slide. Well done. And this why is that? So our test will want to be coded, because if our test is if our views are not tested, because they should be really stupid. They should only care about the layout. So that everything is just laid out perfectly, that the animations are doing great, but they don't really need to know what data are they really displaying. So what we can test, of course, is the view controller's code. So we just inject some objects into the view controller, and then we can assert its view that the UI labels are properly populated, the table views are properly populated, that everything is well formatted, and everything works fine. And the views itself, we need to test them manually. There's no, I think, other way, because we need, even it's hard to test in the simulator how it looks and feels, because we need to install it on our devices and just play with it for a little while and just tweak those parameters up and down until we feel that everything is working so flawlessly and it's just so crisp. And of course, the other day someone tells you that it looks terrible, so you need to tweak them again. And if we are testing those views manually, it's good to ensure that those views are accessed easily in our app during the development stage, because there are a couple of situations that I saw that the developer came into the ongoing project and he didn't even have the privileges to be able to navigate to the certain part of the application that he needed to make some work with, or there is a certain hardware required, so certain UI can appear so we can navigate into the certain part of the application. Okay, so let's just get simple. There is a model layer in MVC model, the view layer, controller, glue it all together, and there is a service layer underneath. Okay, so the slowest connection is between, of course, the web and the service layer. So that is the stuff where all the requests are being done. Okay, so what we can do here is we can, for example, to break this dependency on the internet, because we don't really want to be so dependent on the internet connection. So what we can do is just introduce, for example, some proxies. So instead of asking the original web services, we can provide some JSON data of our own, or we can use some libraries to just create those fake JSON data and put it into our application, or we can just have full control of it and just replace the whole service layer. So instead, using objects that that access the web to launch those requests to the web services, we can just create the fake objects of our own there, or create them from JSON files from our main bundle, or just create those objects there in the memory. And this gives us full control of what's happening. So of course we get quick response times when our application is fully offline. So here is the example of Google sign-in. So originally we go into the Safari, then we need to fill in a couple login password, accept those terms, and then we are navigated back to the application and we are presented with some live data. And of course, if we just remove the Google login in some separate target, for example, the login would look just like this. We tap a button and then we are navigated straight into some fake data in our application. And it's maybe not a big deal because it didn't took such a lot of time, but imagine if you performed this action 100 times a day, every day. So it started to begin a big deal. And of course, we don't need to deal with any server downtimes. So for example, our clients are updating their servers. We cannot integrate with them, so we cannot continue their work when we are offline. Of course, that doesn't concern us. We don't have any connectivity issues on our side, so of course we can just type no matter if the internet connection is there or there ain't. And for example, we can code while we don't have any connectivity at all. So for example, while we travel on the plane or so on. And another example, we can easier manage errors. So for example, there was a situation and that the server 1 on the 20 times returned some very strange error code. And to reproduce this bug, and our application started to begin behaving really strange. So to reproduce this bug, the developer just sat there and launched the request 20 times until he just reached this error that the bug was referring to. If we had this service layer faked of our own, we could just create any error code, any error that we wanted, and just put it and just send it to the model layer. And once we created this this level of abstraction that we can just replace the whole service layer or any other layer, we can benefit forever. We just need to get some time, do it, and then just with a little maintenance, every time some problems there are with connectivity, we just replace this service layer, launch on a separate target, and we're good. So what I'm talking about is to break dependencies on time consuming tasks. So everything that you see that is that took you a longer time, that you need to do it on and on again, it's good to think for a while if we can just create some fake way to deal with it. And for simple example, I was working on the app that was supposed to play FLAC files from the application's documents server, documents folder on the device. And the problem is that those FLAC files were supposed to be there in the documents folder from somewhere. So when the tester got the application, he needed to download those files or get them from someone, plug his device into the iTunes, and upload those files into the documents server. It's a documents folder. And of course, after we cleaned the application, we installed it again, he needed to upload those files again, and on every device he needed to confirm the same upload. And even if we tested it on the simulator, we reset simulators quite often, so every time the simulator got reset, we needed to get this long path to the documents folder on our Mac and just upload those files there. And what I came up with was a really simple solution: just create a separate target, and then in the separate target, when the application did finish launching, I just checked if there are any files in the documents folder. And if there weren't any, I just downloaded from the package that I upload in our local server in our company. So it was pretty fast and pretty simple, and no one would needed to figure out from where those files came from, and so on. So this image, I think, really describes a lot of situations that we are really struggling with some problems, and we are too busy to just have a little bit of time just to, for example, create this level of abstraction so we could fluently replace those implementations. And of course, the longer we are struggling, the harder it would be later to replace those wheels in this wagon. All right, so I was talking now about replacing the whole layers, and it would be great if we had some tool to help us out. And there is one. This is Typhoon. It's the library for dependency injection container. There are others, but I didn't test them because Typhoon just fit all of our needs. And Typhoon gives us the factory object that provides us with fully instantiated objects that we need. And those objects are described in so-called Typhoon assemblies. So every assembly has a bunch of methods that describe every object, every dependency of those objects, how they are created, and so on. So here, for example, it is really simple example of a root view controller that we will inject into the UI window at the application start. So here we create a definition with class navigation controller, because the root view controller will be this navigation controller, and we inject the view controller's property with this array of two view controllers. It is an app for ordering dinners. So there is a login view controller and dinner list view controller in an array. And the most interesting part about this snippet of code are those two lines at the bottom that we are referring to the separate assembly. So our code is made with a couple of those assemblies, and this assembly can be completely abstract. So here we can receive the whole other family of view controllers. So it's great for branding, for example, or of course this is great for this faking the whole layer. So, and it's really easy to describe which assemblies are built into our application. There is just a simple entry in our plist file. So for example, if I wanted to introduce a separate target that doesn't use live web services, I would just replace this one single entry, dinner time service assembly, and create some fake server assembly. And while I'm on Typhoon, it's hard not to mention Typhoon Patcher. So let's have a look at the simple test suite. Here is the setup method that we are creating this factory that I mentioned, and we are passing the array of assemblies that this factory will use. And this is quite a bit of code, but bear with me. This is a test that will check if after view did load, when the request succeeds, the table view will show the received dinners. So the first line, we are patching the network calls with a given object. So here the all magic happens, that we just replace the original implementation. So we don't want to ask web services in our test code, because it would take a long of time and so on. It would be unit test anymore. So here we just replace this object that is responsible for network calls with our own stop test dinner session manager. So it is our fake, and I'll get to it later. And of course, afterwards we are receiving our object under test, dinner list view controller from the factory. And afterwards we just check its table view that it displays data properly in its cells. And there are there are two cells. Okay, so here is how this patching looks like. It's really pretty simple. We just need to create an instance of this Typhoon Patcher, and then we patch the definition. And somewhere in one of our assemblies, we don't need to know which one, there is a definition that has key AF HTTP session manager. It originally just, as it says, returned a copy of AF HTTP session manager object. And instead here, we are just replacing this definition, and we are creating, replacing it with our own object instead. So later, after someone asks for an object, so for example here, as we asked for a this dinner list view controller, it receives a object graph that has this object patched underneath, so with a fake service session manager. And this is what the data I stubbed there, just simple little JSON. Of course, if there was more data, I would just put it in some separate JSON files. And here is how the stop test dinner session manager is instantiated. It just uses OC mock to do this, and the whole responsibility for this mock object is to wait until it receives the GET request on the dinner's address, and its responsibility is to return the success block with the provided fake JSON. Okay, that was a lot of code, so I would like to show you this on a picture. So in this very simple situation, there is a controller, it has his session manager object, and there is a view that is in this view controller. So normally in the tests, we would just stop the session manager and assert the data on that the view is properly populated, that everything is well formatted and populated. Okay, but of course, after lot of period, after some time, this code grows and we extract some other classes. And for example, our object graph becomes more and more complex. So there are plenty of other classes extracted from our previous view controller, and how to manage the testing. So if we would want to create all of these objects and inject them into each other in our test suite, it would generate a load of code. So, and it would be hard to maintain, hard to read. So what is done generally is just stop every dependency of the test object under test and then continue testing. But the problem with this approach is that we would need to make those stubs on all the way. So on every connection that we would need to introduce stubs, and afterwards, after we needed to extract another class from a class, our tests would start to break because there are dependencies being changed, and our code starts to be really tightly coupled with our test code is starting to be really coupled with our production code. What we really want is just to replace the object that we want to replace. We only need to fake the data, the internet connection. So we want only to replace the session manager. And in Typhoon, we already received the whole object graph. And with Typhoon Patcher, we are able just to fake this one object at the end. And what is great about this is that this test that you saw at the beginning, it could stay the same during the whole development of the application. It's really easy to maintain because it can always stay there, and during any refactoring, any structure changes, this test code could stay the same. And of course, if we are doing refactor and our application, of course, is behaving the exact way, and our tests blow up, they fail, it's a really bad design smell. Some people can say that in this example we are more like integrating, testing integration, not unit testing, but I'd like to remind you that here in this example we are testing a very single test case. So we are just testing that if our controller at the beginning accesses the web, it draws this data onto the table view. Nothing more. So pretty simple. Okay, so we were testing now those server. We are fetching servers for data and replace this implementations to receive some fake data instead. And what about server pushes or devices pushes when we get some asynchronous events and we need to deal with them? So let's have a look at the simple example using iBeacons. So let's imagine there is an application that has a really simple case that when we are getting near a iBeacon device, it just appears some UI action. Pretty simple, but imagine that we are working on this application with 5 other people in one office, and we need to recreate the situation that we range only one beacon, and there are 20 beacons lying around in our office, and we are interfering with other people in the team. So how can we deal with it? What happens in such code? All we need to do to get those beacons is instantiate some CL location manager instance and assign a delegate into it and just start ranging beacons. And later on, all we need to do is to just implement this delegate method, and here we receive the beacons array. This is the boundary of our application. We don't really know what happens underneath. This is a code from Apple. the CL location manager. So what we care about is just that we'll receive a good. I hope you see this code. It's not too small. What we really care about is that we just receive the array of beacons, but we don't really care from where we'll receive those beacons, and so we can just create our own array somewhere of beacons. And here I created some fake beacon. It just has the same properties that are required in our application, and just pass it to the location manager's delegate. And now I would like to show you some live demo of the solution a simple solution that I came up with. And because it's the live demo, it can break, so I hope that everything just goes okay. So right, so now I'll start the production target application. And as you can see, the UI action appears. Here I have the iBeacon device, and if I get far enough, it disappears the UI, and if I get close enough, it shows the animation. Okay, pretty simple stuff. But now I'd like to introduce you some solution for this. Here I opened a separate test target of my app, and as you can see, the first thing that appears is a prompt to choose the test server. Right now it's empty because there are no test servers on the network. Here I just launched the instance. It is a lightweight server on Node.js, written in Node.js. And as you can see, the moment it's on, it showed on me the test server. So it is discovered using Bonjour protocol in the local network. So let's just choose this server. And now, after I selected the test server, there is a WebSocket connection established between the server and my application. So now, as you can see, when I'm getting near the beacon, nothing happens. The magic happens when I just send some simple GET requests into my test server application. So here I create this situation that we range some near beacon, and on the second link I create the situation that we find a far beacon, and it works like a charm. Okay, so back to slides. I'd like to show you how it's being done. So what I thought is to be great that we could just the first problem I had was where to start my test code, because there should be some place that I started to search for those servers and establish this web socket connection. So of course we would need to do it in, for example, application delegate did finish launching method. But I wanted to make sure that my app behaves the same exact way in the production target and in the test target. So I wanted to make as little as possible changes to the production target itself. So I decided to make a category on the application delegate, not to use those if-defs and so on. But of course, application delegates can be named differently. They can have different prefixes and so on. So what stays the same in our apps are UI application class. So let's make a category on the UI application class. We need to get access to the application delegates, so we get hold on the set delegate method. We swizzle it and implement our own fake delegate method. Here we receive this original delegate method, that delegate object that we want. We replace those implementations again, call the original set delegate method, replace those implementations again to can have access to the application did finish launching method. Here is our own fake application did finish launching method with options. being called, and after we exchange those implementations again, we can call the original application delegate application did finish launching with options on the application delegate, and then we can just start our test code. And to make those things simple, I just created a singleton that when I pass the method start, it just starts ranging those servers and then establish the WebSocket connection to the chosen one. Yeah. Okay. Here, what is left to do is to just implement make category on the CL location manager. So instead, running this code from Apple that will start searching for those physical iBeacon devices, I need to get on hold from on those messages that came from these test servers. So here I just need to implement the event aggregate object, and this protocol looks pretty simple. It just have one method, and this is an example of the implementation. So here we just receive message 1 or 2 from the GET requests, and if we receive message 1, we create an array of one beacon that is being immediate, and on the 2 we are creating one beacon, an array that is far. So this is how it looks. Instead of iBeacon, we have this test server, we have our fancy plugin. At the start, it's establishing this WebSocket connection, and then through web browser we can just send some simple GET requests to the test server, and after it receives this message, it shows the UI. And of course, there can be many possible ways that we can use this solution. For example, when I was working on the consultant application, there was an app that connected to the banking consultant that we can share chat, audio, and video. And there were plenty of events that consultant could send to our app. For example, those chat messages, and so requests for passwords, and so on and so on. And after each request, we needed to launch some UI action on our app. And the problem was that this consultant application was a Windows machine, and it was quite unstable. And after the connecting to it took a lot of time, and after a couple of connections we needed to restart it. So it was quite troublesome, and we could just introduce such a solution to deal with those connections problems. And I think what's even better with it is that we can now in Xcode 7 there is a official support for functional testing. So we can have our test suite and test the apps that, for example, uses iBeacons, because previously we would need to have some, I don't know, robot that just moves beacons around the office and try to recreate the situation. But now, using this solution, we can just have our test suite, it clicks through our application, and then at some point it just sends a request to the test server. The test server, as always, just calls our plugin, and our application launches the UI action, and then the test can assert that everything went fine. Okay, and I think that will be it. So thank you very much for your attention, and if you have any questions, I would love to answer.
Okay, so thank you.
Thank you.